he was just making fun of the way that I review. But I said, it doesn't really matter because at the end of the month, everybody knows everything, so we're all good. Alright, so relation, talk to me, what is it?
It's a function.
It's not a function.
A function
inputs and
outputs.
Inputs and outputs. Underneath that, we have functions. How is a function different than a relation?
Every input has exactly one output.
Every input has exactly one output. How do we express a function?
In a sequence or in a
No.
linear?
How do we express a function?
Words.
Equation, words,
Mapping
diagram,
coordinate
coordinate plane,
table.
table, somebody said ordered pairs.
You say
I think that's all. So is a function a table?
No.
Is a function a graph?
No.
A function is a relationship, we just express it in those different ways. So, underneath functions we have sequences, which is basically a function except what's special about it? It's in a certain order, the X represents position numbers, Y represents terms. The actual sequence is represented by what values? Y. We also have linear functions, and we have non-linear. Linear is defined by what? No. Constant rate of change, which makes it create that line, right? So constant rate of change, yes. But the reason it is a line is because of that constant rate of change.
Or crop.
And non-linear obviously is
No line.
non-constant rate of change. And so, how do I tell on a graph if it's linear or not?
It's a
Is it a straight line or not? Is this linear?
No.
No. Is it a function?
No.
No. How do I know?
Because the vertical line.
Vertical line test, and ultimately what happens there?
One
One output has more than one input. If this is x equals 3, has more than one output, right? By tracking?
Definitely.
Alright. Yesterday, or we've talked a lot so far about this constant rate of change idea. How do I find it from anything? Rise over run we use more specifically for what? We use rise over run more specifically for a graph, very good. But ultimately slope is always change in y over change in x. And that looks a lot different for each representation of the function. Like we used rise over run, we use that for a what? For a graph. How do we find this, or how do we use this for a table? How can you do rise over run if it's a table?
Oh wait, no.
Change in y over change in x, so basically you go through and you see how do I get from one x to the next, from one y to the next. And then are we just looking for the same numbers down the side? No, because we need to put in a what? Starts with an R. Ratio, we're looking for a common ratio, not necessarily common numbers down the sides of those tables. Everybody cool with that?
Sure.
Same thing with ordered pairs, because ultimately this table is a list of ordered pairs. It's just written a little bit differently. How do I use an equation to decide the rate of change? It's got to be in slope-intercept form. And what is going to be representative of the slope?
The force.
Coefficient of
X.
x. So in this situation, rate of change would be 4. What does that 4 mean?
That is deep. Are we talking about like on a graph or just in
Very good. For this particular function, the slope tells us for every increase in x, y goes up by what? 4. If I had this equation, what does that slope tell me? Somebody other than Adrian.
that for every
Simon.
For every 4 changes in x, y increases by 3.
Very good. What would this tell me, Emma?
That for every 4 increases in x, that's going to go down in y 3 times.
Okay. Everybody cool with that idea? What would this tell me? What's the rate of change in this equation? 1. So for every increase in x, y increases by the same amount. What would this tell me?
for every decrease of x, or one decreases by
Every
x.
time x goes to the left.
Y increases by 1.
Is that true? He said every time x goes to the left, y goes down.
No.
No, that would imply the y and the x are both what? Negative, but when we see negative, only one value is negative, so you have to decide. I would always just say as x increases, what happens to y?
Decreases. Increase.
In this situation, it does what? Decreases by 1. So, well, never mind. Show me the 4 types of slope. Positive, negative, 0, undefined. Why don't I like calling it slope?
Because it's not
Because it's
linear.
We're not always going to be expressing that function as a what? A graph. And so a lot of the times we associate slope with a picture, and that's wonderful, but slope, more importantly, is the rate of change, and you can find that from any form of a function that you want. You should be able to go from a graph to a table to a whatever. Everybody okay with that? Alright, let's talk about, show me the handouts y'all had yesterday. What did we not do?
You did this?
The back.
This one?
Wonderful. Let's look at, no, we are gonna use this, so we're gonna come back to this, don't put this away. Let's look at that one, hold that one up, Victor. Yes. Let's look at this one,
Just that one.
just that one.
Show the camera. I need to put this, thank you. I need this.
Miss Robinson?
Unless you wanna use your pad. Hold that up again, Victor.
So Bryce, so Bryce.
This is mine.
Bryce.
I need one.
Say,
Boys.
you
Don't call me boys.
are.
My name's no boys. It's Bryce. Say Bryce. Wait, Victor, could you hold it up again, please? Victor, say Bryce. Say Bryce.
Alright,
He gets it by then.
so yesterday we talked about how to take an equation. That's something we didn't review. How do I look at an equation and tell whether if it's a linear or nonlinear function? If x has any exponent other than 1, it's going to be what? Non-linear. What if it's, can anybody think of a situation where it looks like it has an exponent of 1 but it really doesn't?
When it's negative
When it's negative 1, which would look like what?
x over 1. 1 over
1 over x. So if we see y equals 1 over x, technically there, it looks like it has a 1 exponent, but in reality it's what? Negative 1 because it's on the bottom, so that would also be nonlinear. What about this? Nonlinear. Nonlinear. Linear. What's special about slope-intercept form of an equation? Y is isolated. What's true about standard form? X and Y are on the same side. What do A, B, and C, what do A and B represent?
Constant.
Numbers, coefficients. What would C represent? Constant. Remember I talked about how the different teachers teach it different ways, different textbooks teach it different ways. In our situation, A, B, and C can be all real numbers, meaning can it be a fraction? All real numbers?
Yeah.
Can it be negative? Yes. Can it be a decimal? Yes. Some people teach that it has to be a whole number, and apparently that opinion varies from textbook to textbook. Ours teaches that it can be all real numbers, so we're going to go with that. Everybody all right with that? Okay, so let's take a look at this handout. Wish you had one too. Up at the top, I know that's frozen, but up at the top where it has that big blank, write standard form in there, the general standard form of an equation.